I think we've danced around the idea of reproducibility a couple of times. I do want to just ask explicitly, we know reproducibility is a huge deal in science, data science, ML, AI. How has Pixi helped you ensure consistency across different environments, especially when needing different types of machines and that type of stuff?
Yeah, Pixi's lock file does the trick. You know what? Maybe it's easiest if I just demoed Hugo.
Let's do it.
Yeah, let's
Let's
just
jump
do it.
in.
Let's just do it. So I'm going to share my entire screen to over here. It's blank. Do you see my mouse?
I do.
Okay. I'm going to go bring Hyper into here. So I have my scratch space, and I'm going to clone LlamaBot as if I never installed it ever before.
And remind us, LlamaBot is your Python utility
That's right.
package to interact with LLMs and build LLM applications.
That's right. And if you're curious about it, LlamaBot's right there. A few that's the README. You can pip install it. It works with local LLMs. It works with API providers. I have an API switchboard called Light LLM to thank. Like the developers of Light LLM have done a really good job. And I'm just going to while we're here, I'm just going to quickly show PyProject.toml where the Pixi configuration lives. So there's the project. These are all the dependencies of that LlamaBot requires. And let me just see here. Notice the Pixi configuration. It supports currently 3 platforms, Mac OS, Linux, and right. And so then there's like different types of environments, right? So there's like environments that are just for those who want to run notebooks, environment for just building documentation where you don't need all of the things that are involved in software testing. You don't need like code linters or any of that. So I can have these environments. I think the term we've called this before is like composable environments, where I can have so-called features. I actually just think about them as like components of a project, and there are components that are needed for running notebooks. Some dependencies are needed for like my development tools, etc. So if I go back to Hyper over here, I've got myself set up over here. Let's open cursor over here. All right. And if I were to very quickly PyProject.toml and look for the tasks, I can in an almost instantly run, say, make docs. I can run JupyterLab, for example. Pixi run JLab, and it's going to start solving the environment for me. Let's give it a moment.
Yep.
It's pretty darn fast.
Yeah. It's incredibly fast. And once again, this is because it's rebuilding all of Conda, among other things, on Rust.
Yeah. And so then now it's going to run JupyterLab. And I didn't rehearse this, by the way, so I don't know if this is going to work immediately. But if it doesn't, I'm nonetheless going to show like how to do documentation, building docs or previewing docs. That as well is like a thing that Pixi can do. So let's just let that run for a little bit more.
Sure.
Meanwhile, in parallel, I'll just do this. So Pixi run docs. Oh, look at that. I didn't get to run Pixi. I didn't get to do that. So there we go.
It was too quick.
That was too quick for me. Right. So then like it opens up directly into the notebooks. And I have a few example notebooks on like how to use LlamaBot. SimpleBot's the easiest one. Let's see if this works. Oh, I'm missing that blog text. Okay. Didn't put that inside there. I have some outdated things I need to work with. But yeah, LlamaBot's installed. I can just, if I'm interested in just exploring, right? You can see the use case here. All I need to do is go in and go Pixi run JLab. And now I have myself JupyterLab open. Hugo, imagine we were doing this as a SciPy tutorial, right? Just imagine like, I forget about the Dockerized containers, the VS Code, dev environments. It's just Pixi run JLab. And now we can start teaching.
It's incredible.
That's pretty amazing.
Yeah.
Okay.
Absolutely.
So I'm going to close the window and come back over here. Let's exit on the right-hand side. Okay. So let's do Pixi run docs. It's going to immediately start trying to serve this. Do I have documentation issues? I don't think so. There we go. Here's my LlamaBot documentation. There we go. There we go. Right there. So it gives me the
Wow.
confidence. I'm ready to go ahead and work with it.
So you just built all of this,
Locally. This is on my Mac. And I can actually show
yep,
this.
using one Pixi command.
Yeah, pretty much. I'm going to do this one more time, except I'm going to do it on my GPU tower. So Mosh GPU. So now I'm on my Linux box at home. It's not too far away from me,
Hmm.
just a few meters off. Make their scratch space. And then repo clone. Okay. And then so cd LlamaBot, Pixi run docs. Do its thing one more time. Now I think I set the host to 0.0, so I should be able to copy in my GPU tower's IP address and just go straight there. Let's just see whether that is the case. And if it's not, I know exactly what to edit temporarily so that we can make this work. But the main point is all I did was Pixi run docs and it gave me make docs serve, executed make docs serve, most crucially within the correct environment, right? So it knows and is aware
Yes.
of LlamaBot. It knows and is aware of the dependencies that LlamaBot needs to run, and it knows that it needs make docs in order to run. So I don't even need to. So for people who are interested in like notebooks only, they don't have to worry about installing make docs. They can just run the notebooks.
Mm.
Yeah. Okay, so it's just taking
Wonderful.
a bit of
And
time.
just I think this is probably obvious, but the fact that you've been able to do the same thing remotely on a GPU tower that you did locally, the same single command to get this up and running, is pretty powerful.
Yes, 100%. And I think that's really important because it simulates that situation where I'm going to take my work and I'm going to give it to my colleague. They're going to run it on a completely different computer hardware. Okay, that address is already in use. I know what to do. Well, address this point first. My colleagues are going to run their code in a completely different piece of hardware. So what I've just done here is simulate the situation where someone needs to reproduce something, right? And so they can run a
Mm.
single command and all if they have nothing that the system level that is blocking them from running the command, they will be able to run that command. In my case, I have a system level address already in use problem. My project.toml. Let me search for docs and make docs serve. I think 678. Let's try that. So I'm going to switch the default port to port 5678 and let's see if that works.
Hmm.
Okay. Pixi shell e docs. And this lets me enter into an interactive shell with my LlamaBot docs environment activated. And so I can basically I should have make docs, which make docs, right? It's present, right? So I can do make docs serve
Awesome.
help. And I got the argument wrong. It's -a and then IP and port. So the default is localhost
Yep.
8000. So if I go to there, look for my -p, I switch that to -a and do 0.0.0.05678, save the file. And then I can exit out of my environment. So I'm no longer within the shell with the activated environment. Pixi run
Hmm.
docs one more time. Let's just make sure this works. Now it's here. Now, because now it's being served at 0.0.0.0:5678/LlamaBot, because that's my GPU tower, it's remote, I actually need to get its IP address instead. So I'm going to get my network devices and copy the IP address of my GPU tower and go to my browser, 5678, and let's see if this works. Yeah, it did work. There we go.
Amazing.
So I'm on my GPU tower now. This is so powerful for like reproducibility if you think about it. So
Yeah.
I'm really happy with it.
Fantastic. Thank you for that demo. And I think I did want to chat a bit about containerization. I think this dovetails really nicely into it. We both know that containerization is such an important part of modern workflows. So I'm just wondering for you how Pixi fits into the process of building containers or managing GPUs and CPU environments and all of these things.
Yeah, so definitely it was something I was curious about. I actually did a repo to test this out. So let me just see if I can pull that out. GitHub Scratch space repo clone Pixi CUDA environment. Yes, that's right. And then cursor here. So let's go to the Pixi CUDA environment. Okay. So one of the things I was really curious about was the idea of, can we make this container run in within a CUDA enabled environment, and how do we do that? So one of the things that I spent quite a bit of time trying to figure out, was how do we create a Pixi configuration file where we have CUDA enabled platform version, like package platforms and package versions, but also enable this to run without CUDA, right? So if you look at
Mm-hmm.
my Pi project.toml, this is its configuration. This is its set of dependencies, but I overwrite for the CUDA environment jaxlib with CUDA 12 that it must be present. And it turns out this is the minimal set. Apart from system requirements, CUDA equals 12, and this specification for jaxlib, it turns out this is the minimum requirement needed. But you'll also notice I have OS X ARM64 here, which means I'm not going to be able to run CUDA
Mm-hmm.
hardware enabled environments here. So let's just try this. If I look at tasks, I can go to Pixi run test, and it will just run PyTest on testarrays.py automatically for me. It's going to pull in the right versions without it being CUDA enabled, and that's going to work. One of the reasons why I was really curious about this in Docker is because at work we ship Docker containerized command line tools on the cloud that enable laboratory scientists to be able to use it. And I thought
Mm.
that was like, yeah, okay, we need that, right? We need to be able to solve the problem of, can Pixi run within a Docker container? Because if it cannot, then I can't guarantee that the exact environment that we solved for on my development machine is going to also be present inside the Docker container. That is a necessary condition that must be true for Pixi to work. And then also, I was solving this problem, thinking about this problem that I'm encountering at work, but also thinking about, if I want to ship something onto containerized, want to ship a containerized app onto my GPU tower, but I'm developing on my Mac, like, I need to make sure that they're going to be compatible as well, because I host for myself on my GPU tower a Doku instance, which is just basically a platform as a service, but I want it to be GPU enabled. So that's another like requirement that I have. So solving this Docker file problem was very important to me. So it turns out this is actually not too difficult to do. Um, you can start with a Pixi container. You don't actually need to start with an NVIDIA container. And I document this in my blog post as well. You can start with this container, copy in the lock file, copy in the PyProject.toml file. And if you don't have any other dependencies that you need to worry about, like other source files inside here, you literally can just run Pixi install and install it with a CUDA environment or without the CUDA environment. In my case, I want this container to always run within the CUDA environment. So it's going to do that. It's going to install the CUDA environment inside the Docker container. And I remember that there was a entry point shell script that I needed to ensure that every command that we run starts with Pixi shell and activates the CUDA environment, and or it runs without the CUDA environment. Both are doable. And this turns out to be the way to make this work. If I were to just come back to Hyper over here, And I can go back to my GPU tower, Pixi CUDA environment. I can do a thing where I do, how did I do this again? So I would do something like Docker run. Actually, I'm going to need to refer back to my personal documentation, aka my blog. It's time to try out Pixi.
A
And
great example of us writing things for
yeah,
ourselves as well.
exactly, 100%. Look for Docker, and then I could build the container. Just make sure I have it still. Yeah, I do have it still. Perfect. So let that run in the background. And here we go. Docker run this guy. So I can, what this will allow me to do is it'll allow me to run the bash shell within the Docker container. Let's make sure this works. Oh, it may take a little bit of time. I'm gonna in parallel let this run in the background. And let me just see if this, yeah, okay. I must have done a Docker system prune, something like that. Cleaned out my system. Maybe in the interest of time, Hugo, the best thing to do is to have people look at this as the example. I documented it all in my blog just to make sure that I didn't forget anything. So this was roughly June July when I figured this out. And yeah, basically you can see over here that I can run stuff within a Docker container with CUDA enabled, with a CUDA enabled software environment, but done without a Docker container that was base container that had the NVIDIA CUDA stack inside there. So this is like really cool to be able to see that happen.
Amazing. So it abstracts over a lot of the details that you don't necessarily need to futz around with.
That's right. And if we have this kind of pattern for the packages that we need, like we'll pull in the right versions of stuff, including the CUDA stack, which I learned from my blog post about why is CUDA so difficult. I actually learned from some of the folks who are in the SciPy community, Vias and John Kirkham, about how the latest version of CUDA toolkit, so I think CUDA 12 now is like entirely on Conda Forge. So you don't even have to go to the NVIDIA EULA page, end user license agreement, sign your life away thing. You can just Conda install something that depends on CUDA, and if that something is configured the right way, it will pull in the latest CUDA correctly. And again, I have another blog post for myself to document that so I don't forget it, or I can refer to anytime I need to.
Awesome. And we'll link to your blogs in the notes as well, because there's a lot of wisdom and hard-earned wisdom in there.
Blood and sweat.